All right. Well, it looks like we have everyone back. Thanks so much for joining us and staying with us this morning. I think we had a great morning session and really appreciate Aisha from TI led a wonderful session. And we will have these available for on-demand viewing. I know we've got a lot of inquiries from our academic community wanting to participate today, but they had some scheduling conflicts. So we will have it available on demand, as we will with the remaining sessions over today and on Thursday. And at this point, we will be spending the next hour having a conversation about integrated engineering curriculums. How can industry help? And this will be moderated by Sid Delawali from University of Penn. So we'll go ahead and have Sid take it away.
Hey, thank you, Kim. Welcome, everybody. And welcome all the participants who I saw were also attending the previous academic panel. And I think the idea behind these two panels was to spotlight perhaps a need for at least looking for ways to reinvent the curriculum. And one of the things I saw, because I was Zooming a lot last year, it gave me a chance to actually know some of our seniors much, much better, is they felt whether they were questioning if they were ready for next 30 years or 20 years in their career. And are they ready for learning new things like quantum and things they have not been exposed to? So if graduating students aren't so confident, can we bring some energy back in our curriculum so they have a great foundation, and then they have a chance to specialize if they want. Okay, so there is this element of integration early on, which is building a great foundation, and then giving them a chance if they find that one of the things really appear to be very exciting, that they can pursue it. And hopefully the integrated approach would work. Okay, so I want to share one slide, two slides that we've been tinkering at Penn. And so wait, I can't share. Okay, now I can. Thank you, Sydney. And so this is the curriculum we are tinkering with. And the biggest change we did in all of this is to create pathways after the third and the fourth year for them to at least know by taking what kind of classes will it give them access to the language and the content of the specializations. Would they be able to say, I want to take quantum and I love it, I found it. But for that to happen, for them to become excited, you have to build the base. And so we have this sophomore base, which is devices, which is more of semiconductor physics and nano, circuits, the classic circuits, okay, and then data and signal processing. So they're actually going to do a ton of signal processing, a ton of Python in the sophomore year. The other things we took over, which was not making the college happy, which is College of Art Sciences, is we took over physics. And I thought that has worked very well. That was the single most important thing we could do, which is take back the physics, because so much of electrical and computer engineering is physics. And if you don't prepare them for the foundation in physics, which includes knowing boundaries for semiconductors, boundary values for optics, okay? Because physics department still teaches it in a very, very classical way, and they haven't actually moved on. Whereas ESE, the electrical and systems, which it is known as Penn and instead of ECE, we own the content, we own the delivery. So it made it so much easier for us to pass on the material. But anyway, I just wanted to put this out we have amazing, amazing panelists here. I have known all of them from other panels, okay? And they're all favorite, wonderful friends of Isida, you know, Wilson Lee, Patrick Kane, Niku Rumia, YC as always, okay? And what I would do is I'm gonna stop sharing. I'm gonna let the panelists take over the screen sharing. And Wilson, if you don't mind kicking off with your slide by sharing it, please introduce yourself and then the slide. Thank you so much.
Sid and team, thank you. Let me see if I can get technology to work. Let me know. I hope I'm sharing a slide. Let me know.
Yes.
Yes.
Working.
So good day, good morning. My name is Wilson Lee. I'm the Education Market Segment Lead at Tektronix. It's a great honor and a privilege to be on today's panel, a round of integrated curriculum. And I think tying to the earlier panel with the notion of earlier pathing and immersion for our students at large to really help nurture confidence in their journey to their careers and their aspirations. The slide originally was really to share a point of view, but I think just given the energy in the last couple hours from the beginning panel, it's really more around talking about where industry can and should help on an ongoing basis. But I thought I'd like to keep thematic to the slide, just what are some of the trends and inflections which impact both academia and industry alike. And I thought just to underpin what impacts us both really is around the pace of innovation. There are a number of examples I think were discussed earlier in the panel and previous, but I'll share two. One around of the trends and inflections around of advanced wireless communication. Simply to say that we see growing levels of attention and research in 6G terahertz testing, while industry is still, I would say, midstream in deploying commercially 5G networks. It's simply to say, again, tying themes earlier around the importance of analog, digital, and RF domain expertise that are going to continually be needed to navigate through the system complexities of building the next generation wireless communication systems. I think other to share as examples is quantum research and computing. Just the level and the pace in which we can see invested dollars in the levels of billions, both at a governmental level, but I think private sector. So I think also tying to the enormous amount of incubators and startups that are popping up, I think not only across Americas, but globally. And I think tying just to sit your commentary around of this tying not only classic physics, but mathematics, electrical computing, mechanical engineering, but I would also add both system engineering as well as material research in the aspiration of getting electronics to get closer and closer to these really extreme cryo environments that are in millikelvins near absolute zero temperatures. But simply to say, I think that also underpins current gap, particularly in quantum, in a shortage of workforce. Simply to say that it just actually recently highlighted last week from a White House report out on quantum information science and technology. And I think really thematic to the discussion of how can we immerse our students, not only in the basics, but allow them to select and choose deeper areas of disciplines, particularly those that are emerging in industry. So I think how can industry help? I think there are a number of themes that I would offer this panel and ACEDA at large, which is supporting those application-specific contents based on what the industry is struggling with today across disciplines. Again, the two examples are are thematic, but not the only examples. And it's content that not only reinforces kind of that theme of ramp up, but I think can also go very deeply into things such as time correlated multi-domain measurements that are needed for over-the-air beamforming in 5 or 6G, or how Python is actually used to design quantum hardware electronics. And the delivery systems can be many. I mean, they're digital, they're printed, but can live in the forms collaboratively or in terms of in-person workshops, seminars, certainly leading to new and joint developed curriculum. I would add a dimension that there is a business kind of application that can be part of the enablement. That being bringing business systems or practices in industry around of how to augment and improve problem solving, experimentation practices, how to fail and how to embrace failing fast. Just amongst the many things that, again, where industry can and should continue to lean in to help the cause. I think the third, in terms of the representation of the circle of life, really is what's in the toolkit. So hardware, software, and so-called solutions at large really speak to not only systems in which industry is calling for and the reasons why, but in a way that it's scalable. So that ultimately, even if we have students who are really passionate about getting on instruments, moving knobs, and so on, it also speaks to those who are a little skittish or may just be having that rare requirement to be on bench instruments, but ultimately being intuitive and user-friendly. I think there is this notion of while we want it to be in person, there is a need and a benefit of also having virtual environments. I think the earlier discussions of how students have become mentors and kind of become the teaching environment, there is the call for students wanting to actually share from a peer-to-peer point of view, and where virtual environments may be required either cross-department, cross-country, or even cross-ocean, cross-culturally. I think the last notion that I would share that certainly, what success would look like certainly is, again, a student who's more confident, but I think the engagement would be not only that environment of one to few or one-to-one mentorship, internship placement, and certainly placement into industry, whether it's a flagship name in industry or a startup environment. I think last, we certainly can't forget the notion that of all these great ideas to ensure that we ensure access to the underserved that might live in the MSIs at large, but I think also calls for earlier engagement, whether it's startup programs in STEM, for those aspiring students who may not even really understand the beauty of engineering. So I think the time to talk about something that I'm very passionate about, and I think I will stop sharing and hand it off to the other panelists.
Thank you so much, Wilson. All right, okay, you got it unshed. Okay, Nico, you want to take over? You want to try sharing everything part?
Yes, thank you very much. Let me see. Oh my God, which one is my screen? Maybe this? Yes, this must be it, sure. Let me know if you can see my slide.
Works great, looking great.
Oh, okay, thank you very much. Nope, that's not it, stop here.
No, you were right. I think it switched to presentation mode in PowerPoint.
Yes, yeah. And slideshow. I know how to fix this. It's the view and reading view. Maybe now it's better, yeah?
All right, not yet.
Oh.
It's not.
We just see your face.
Okay, let me go back to the Zoom thing, share the screen. Teams. Okay, then if you don't
Looks
mind, I
great.
will keep it like this.
Yeah.
It seems that if I use the full screen, somehow Zoom doesn't consider it my my desktop anymore. Okay, so
That's great. Yeah.
okay. Hi everyone. I'm Nick, product manager with Red Pitaya. Thank you very much for organizing this and for the invitation. I'm really honored to be here and you know, to share my experience as a former European student, but maybe more from the later period as a technical sales consultant for two really nice technology companies. I definitely noticed that for students, the most practical and the most relatable to the real world you can make a course is the most interesting. And that is actually how you make it easier for them to learn, and where you see that the students have the most focus and creativity in their projects, right? So yes, initially I heard the question that should the academia go to this integrated engineering curriculum? I don't think it's a question about doing this and interdisciplinary cross connections. I definitely consider it's a natural evolution. And also, yes, I have seen it already starting to happen from my position in my experience where I have been working. You know, thinking about the student challenges, right? They have so many, but if you want to analyze it, I made a top 3 challenges, and I think one of them, it's definitely tilting this balance of theory to practical, right? And as I mentioned before, as practical you can make a course, the better. And there are challenges, like smaller challenges with that. The second challenge I would see across a few European countries, it's access to hardware, right? And not only because of COVID lately, which actually separated physically the students from schools and from the laboratories, but individual classes, where I saw them, they have individual laboratories with their own equipment that can be limited. I'm sorry to say, but not to point fingers or look down on the academia. That's also what I lived and learned. Some equipments might be old or single purpose intended. And I mentioned here quality of the tools. I refer to the cases where some laboratories still have equipment older than 20 years, you know, and they might work perfectly, but the technology evolved and now there are new needs and new technologies, new classes, new courses, let's say. Yeah, not only the student has to learn the concept, the theoretical stuff, but every time they also have to learn a new instrument, how to operate and how to do the measurements in that class, right? And when they graduate and go to the industry, they will no longer see that particular, you know, maybe old instrument. So this kind of work, it's put in, but not used after that. And the last challenge, it's about new technologies, right? New technologies emerge faster than the academia can actually implement them in a curriculum. And again, not academia's fault. It's just logic, no way around it. And you know, with the reduced set of functions, and maybe better said, without the possibility to reprogram the said tools or update them, it makes it very difficult for a fast implementation. And yeah, I will stop here. Let's talk about these 3 challenges and actually how the industry, from my point of view, of course, how it can help here, right? So in my opinion, we can use the design knowledge and the experience to bring out a hardware tool that is one of the three things, right? It has to be a tool which is new age, like a smart thing, versatile, open source, to have a broad coverage, So after graduation, students will have a wider job market opportunities. And it's not just like a tool, like a piece of instrumentation. It can also serve as a built-in to something much larger, right? The second most important thing, it should be affordable. This is very important for academia to have affordability. And yeah, it is a challenge for the industry to create such tools for the academia. And number three, it has to go the route of high performance, right? Because this will actually allow the students and the teachers to tackle a wide range of new disciplines and technologies and even research area, right? You don't know exactly what parameters you will need before you jump into research. To recap, that's my opinion. We would need a hardware tool that is smart and versatile, affordable, but at the same time high performance, kind of like a Swiss Army knife for engineers, right? Oh yeah, and additionally, the industry can collaborate with the academia, like even through this kind of conference organized by SIDA, to provide academia members with a platform for integrated curriculum sharing, right? If one university develops a class, like actually I've seen this for building radars, there's no point of doing this effort again for similar kind of classes somewhere else. It would be really nice to have a database with these courses and with these projects. And okay, we already kind of started working on this and we have some of them. We long time ago, we dedicated a product line specifically for that. And we know that it works because we have seen it already in use in academia. And like I mentioned here in the green on the left side, for learning electronics, like basic circuits, measurements, filter design, data acquisition, all of this. And in the hands of like particular schools, we have seen really interesting projects. I will just mention 3 of them, but we can have all day talking about MIT had a budget like $500 and they built a tabletop MRI machine, right? To scan the fruit seeds without cutting them. And Princeton, of course, they did the nuclear head verification. They actually had a tip of the missile inside the classroom. And so the why I said about a tool like that, it's because the students can use it while learning and doing their projects, and exactly the same tool, it can be used in the industry later, as we actually seen a lot of companies designing systems for measurements, doing remote data acquisition, even new photonic instruments they were able to do because of the performance, radar, LIDAR, spectroscopy, a lot of robotics, and even quantum computing that we actually are not experts in this, but we, as engineers, we got together to the common language and finally, brought together the perfect variant for them. That's all from my side. Thank you very much for your time. And looking forward to the later session. Maybe if you're interested, you can also see the demo from our side. That's all. Thank you.
Thanks so much, Nick. Really appreciate it. A lot to digest from the slide. If you can stop sharing, then Patrick can take over.
Stop sharing, pause sharing. Is this okay?
No, you should stop.
Okay,
Zoom
stop
sharing. Yeah, there you go. Okay.
Now, if I can share my screen. That's not what I wanted to share. Okay. Right. So I am Patrick Kane. For the last 15 years, I've been the director of the Cyprus, now Infineon, University Alliance program. So probably many of you I've met at various conferences and maybe done workshops on your campus. Prior to that, I was the manager of the Xilinx University program. So I've been doing this for quite a while, and I took this quite literally. So let me just throw out some food for thought. And as Nick just said, and Wilson to some degree, that we in industry have to work with academics to provide. And in this case, I've been a big fan of online teaching, online materials as a way of democratizing education. So it's available to anyone with an internet connection, basically, whether or not they have the opportunity to go to a university. But in the sense of the traditional academic world, these online materials can be used and have been in the past as pre-work or homework, so that perhaps, I'm working on something right now where students will be able to earn a digital badge after completing a short course, and a professor may, or an educator may require the student to show them the digital badge as proof that they completed their pre-lab or their pre-work. So, I mean, if we don't work with academics, we're not going to get, and when I talk about we, I talk about industry, we're not going to get the students with the skills we want when they graduate. So we have to, this is a partnership. For you at universities, the students are your customers, and we're also your customers in a sense. It's a two-way street. So the other thing is to provide hardware that can be used across multiple disciplines and courses. Now, I have, as I said, been in this game a while, and I've seen the cost of the hardware go from hundreds and even thousands of dollars down to like our least expensive MCU kit right now is like $5.75. So it's certainly gotten much more affordable, and you can do much more things with it. Now, one of the products, PSOC, Programmable System on Chip, has a analog component, op amps, comparators. It has digital, and it has an MCU. So you can use this across multiple courses, digital, analog, and MCU, but also disciplines. So I'm seeing, and one thing that Sid's initial slide, I had a thought that I wrote down, is that, well, engineers today, while there are specialists, they also need to be generalists to some extent. So you can't just, unless you're really, really good on the cutting edge, you're not going to get away with being just a specialist. So a mechanical engineer needs to know some programming skills, whether it's Python or something else. And actually, the message I've been getting from universities is that, if your stuff is not programmable in Python, then the mechanical engineers will never figure it out. So I think that's a key component. So even if the hardware is fairly expensive, and these days fairly expensive is a couple $100 in terms of a lab kit, if you can use it and amortize that cost over 2 or 3 years or even 4 years, then it becomes more affordable. And the next thing is to, as an industry, and Infineon in particular, needs to support relevant student projects. So one of the key areas we're working on as a company is artificial intelligence and machine learning. Climate change is a big push at Infineon, and how do we use our technology to solve these issues? And we can support student projects, which gives students actual, industry training. Leads into the next bullet, which is, provide a robust intern program. So what Bill Kaiser had presented earlier with their freshman course in using the ST products. Well, my comment to that is that students who have accomplished that become useful interns earlier than they would have been in the past. In other words, a first-year engineering student in the past would know some math and might know what a resistor or a capacitor is, but they haven't really started their journey on engineering. But now with a course like this, you can get interns into the company earlier. And we do have a robust intern program. So what I would say is, I guess if we have these breakouts at the end, if anyone is interested in collaborating on working up some materials or some ideas, join me in the breakout room and I'll be happy to work with you on that. Still early days for me at Infineon. We're still kind of a Cypress side and an Infineon side, but there's lots of new toys in the toy box from an Infineon side, lots of sensors and power electronics and things like that that I never had the ability to work with at Cypress. So so this is just some food for thought. I look forward to a robust discussion as we move ahead with this panel. And I'm very happy to be here, so thank you.
Thanks, Patrick. As always, YC.
Thank you, Sid, and thank you very much, Patrick. The food for thought was quite filling. And I have to say that you covered a lot of points that I wanted to cover, but I'll try my best to top that. Okay, let's see here. Let me share my, I used to say every time I hear someone say, let me share my screen on a conference call, if I get a cent for every time I hear that, I'll be pretty rich by now. But let me share my screen. Give me a second. Okay, can you see my slides?
Yes.
Okay, perfect. So I will not go into presentation mode because that may just bring things to a different screen and may cause problems. So I'll just talk directly from here. But I think this will also give you a good flow, and if you peek on the side, it will give you a good indication of where I'm heading. So let me move this out of the way, this window here. Okay, great. So, okay. The concept or the topic of threaded curriculum or integrated curriculum, right? It's like that parable of 3 blind men feeling an elephant. Some people say it feels like a tree. Some people say it feels like a snake from the trunk, right? So there are multiple different interpretations of what it means. And an interesting thing is when Sid and I were planning this this panel session, we actually discovered that multiple universities have multiple different interpretations of this. So we heard from Professor Kaiser earlier on, his views of this. But ultimately, I think the one central thing that's tying everything together, right, would be where students are headed after they graduate. And I've been on campus a lot prior to the outbreak, and I've talked to professors, and also, well, a lot of universities have me talk to their career people as well, because, well, you know, I represent industry, and very often the career people on campus are very interested in you know, my company potentially sponsoring internships and things like that. And in the course of discussing these things with them, I discovered that a lot of students are actually not very aware of their career options. And I feel this is very important in, you know, the threads they pick up, okay, in a threaded curriculum like what you have at UPenn. And that should go hand in hand. So I don't know how much UPenn does in enlightening their students on the possibilities, but I also would assume that, you know, just by being in UPenn or one of the competitive universities around the country, the students will generally have a better idea of what they want to do. But in general, I feel that, you know, are they aware of this? And I've shown this slide earlier on, and I'm happy to show it again because, well, you know what, this is a question that has been, you know, a hot topic for a while now. And I built this for 2015. Kim from ISITA reached out to me and said, could you build a slide on possible career paths for students? And it took me a while to think. And I think what I show here still is pretty relevant even though I built this in 2015, sorry, not 2005. And so do they see a connection between coursework and real life? This is a sample, a slice or cross section of what students could potentially do after they graduate, right? The skills they need to pick up while in college, or maybe doing their post-grad work. But how many of them are aware of the possibilities out there, where they start and where they could potentially end up in? I think this is a very important thing. And Mihir presented that wonderful slide on all the electrical engineering knowledge that one will need for acing any engineering interview. That, by the way, that slide is golden. I love it. And I think that a lot of what he's showing there actually resides right at where the X and Y axis crosses. And so this slide may be a little confusing here, but then the lighter portion of this is earlier in a student's career, right before they graduate. And then as the triangle gets darker, that's when they progress into the niches, or where they choose to settle in the industry. What Mihir showed earlier on are a set of key skills needed before, I feel that before a student even jumps into a particular thread, before they even jump into a particular curriculum path to take. And so I feel that by knowing what their career options are, they'll be able to make good, informed decisions as where they're going to in the industry. And then they will be able to say, okay, because of this, I know I need courses on DSP. I know I need courses on RF. I know I need courses on feedback and control systems, or advanced concepts of that. But before that, it's I don't know if they're completely aware of this. And I feel that this is where industry comes in. This is where the industry can step up to the plate and basically show students what the possibilities are. Why would you want to work at Tesla or Infineon? Why would you want to be a technician? Sorry, not a technician. Why would you want to design PCBs versus why you would want to design products for, say, a engineering design firm, right? And these things, I feel that students from an earlier generation, maybe a couple of generations ago, they understand this. They come into the university with already with a burning passion for electrical engineering, and so they already know, okay, I want to take this, I want to take this, I want to take this after I'm done with all my general electives. And so they know. But with this current pandemic that's going on, and the shift in focus from hardware to software, I feel that a lot of this got lost. And this is where companies like DigiKey, companies like Infineon, companies like Repetaya or Tektronix can jump in and say, you know what, we can show you where potentially you're headed, and then we can show you how to get there. And along the way, then the student will determine, is this something I want to do or not? Is this something that I'm interested in or not? And that will then tie in. I feel that there has to be a tie-in between what Sid showed in his slide of what UPenn is doing with this slide here, of how what threats a student can take can lead to possible jobs here. Of course, again, this list needs to be updated, but I think it still is very, very relevant here. And so, right, where do we, this is from a fictive 2018 State of Hardware report. They have newer reports now, but I feel that between 2018 and now, we have a year and a half of just, aimlessness, I guess, in general. So I don't count a big portion of 2020 or 2021 as being as having changed too much. But where do they go after graduation? If you look at the top 1, 2, 3, 4, the top 4 industries, they go into consumer electronics, medical devices, industrial robotics, and something became ... So that got cut off, automotive and aerospace. So you know, they most students after they graduate go into those areas. And so our universities' threaded curriculums and coursework, are they targeting these areas? And how often do these courses get refreshed, right? To Wilson's point, you know, universities often need to get feedback from the industry, both from the local industry or from companies that are doing cutting edge research there, right, on what needs to be communicated back to the students. And that communication should happen so that students can say, you know what, I've taken a couple of these courses, I'm really not happy with what I've taken, I want to change this to that. And so from that, then I feel that universities will start discovering a solution to the issue of students dropping out and changing majors to mechanical engineering, computer science, and so forth. I feel it needs to be communicated across that, hey, programming languages, I know they're a big deal in computer science, but they're a big deal in embedded engineering as well, because that's how you make a device work for you. And so, and from that, then they will be able to make the right choices and then land in the right portions of the industry. And ultimately coming back here, you know, essentially to the employer keywords for San Diego, DigiKey did a quick survey of all the jobs in San Diego that are looking for entry-level students, new college grads. And, you know, and I've also taken a peek at other geographical areas, Phoenix, Indianapolis, also Philadelphia, since Sid is hosting this. And in general, the keywords are generally the same. So I think they're looking for the same basis. And this correlates back very well to what Mihir showed earlier on. So ultimately, I feel that, you know, beyond, you know, the few halo companies we have, you know, Apple, Tesla, SpaceX, students should also be aware of what else is out there, where the courses they take in the curriculum will take them. And, you know, to Patrick's point, and also maybe Niku's point, right? Reusable hardware is really critical, really important, especially after graduation. They may not have too much money. And if they can have one piece of hardware that will do multiple things, that will teach them multiple concepts and hit as many keywords on here as possible, I think that's golden. So I'm done with my presentation now. And Sid, I'll hand the reins back to you as soon as I figure out how to stop sharing this. Okay.
Thank you, IC. Really appreciate it. Audience, we're happy to take your questions over chat. If you feel confident enough to speak up, please do. Happy to feel interrupted here. I certainly have quite a few questions, but I'm going to wait for 10 seconds to see if somebody wants to speak up and ask the question.
I said, so as a parent, I watched my son get educated by the local system, which was quite good, but they would insist on doing things when he was in second grade, teach him viscosity. And viscosity is an advanced concept, and I kind of viewed it as a post-it pad education. Okay, my second grader can now say viscosity, but he didn't have any deep understanding of it. And a lot of the things on your last slide are, yes, you know, we've got to teach the students Python, but if we try to cover all the catchwords, then we're not giving them a deep education. And really in academia, we teach them how to learn. And to teach them a little bit of everything, I think we'll have done them a disservice.
let me respond, this is Patrick. So yes, I agree with you, but I would say that we need to you need to teach them how to be lifelong learners, basically. And this goes back to our previous conference earlier this year, I think it was in July. And so at some point, certainly not a second grader, but it's certainly by university, students have to realize that they are really responsible for their own learning. They are, the professor at that point is a facilitator and not really, you know, a teacher, what they used to call a sage on the stage. And there's so many opportunities now, both online and with the increasing affordability of hardware, tools and things that students can, you know, follow their passion, if you will, in an engineering sense, in different directions. And it's up to us, I think, to give them that opportunity.
Yeah, I would like to say just 2 words. Back in my time, I would have loved to get a little bit of everything because it would give me a wider view. And then when I want to get professional about it, at least I know about the field. So then I can do the research on my own. I think it's for the better. Maybe it's, you know, viscosity needs a better presentation, but I don't think it's worse that he learned about it or that it's too much early on.
I trust Wilson, you have your microphone unmuted. Yeah, please go ahead, Wilson.
Alan, thanks for the question. I think the perspective I would add to Patrick and Nico's comments is it's a balance. So I don't think it's a so-called digital 0 or 1. I think underneath of that is maybe a couple of thoughts around each university, a student body will be a little bit different. So I think while the hope of this summit is an intentionality, particularly as where industry can help academia, I think maybe it speaks to a little bit of potential experimentation. That's to say, kind of change in SIPs, maybe through a summer course versus a fallout semester or term. But I think the question is a valid one, but I would say I think the future is maybe somewhere where it's a blend, and again, depending on each university. But I think the challenge of how to get students more, I guess, through this summit, not only confident, but in a way bold, because underneath lives, I think, those who really want to kind of innovate and change the world. So just giving them that pathway where there's a mix of going deep I think in combination with at least being exposed at a high level, areas that they may want to specialize as they get to their junior and senior years.
I agree, it's not either or, but speaking as someone who wants to innovate and change the world, really helps to understand things well, so that you understand the black boxes. And when you understand the black boxes, then you can make new black boxes.
And so I totally agree there. I think the context is very important. And using the example of viscosity, I don't know what your local school system taught, other than the idea of viscosity, but how it relates to real life, how it relates to everyday things. And so, dropping a keyword like Python, okay, that's out of the blue, and that's a very specific skill. Students can pick that up from a community college, or maybe even learn on their own with one of the various YouTube classes around. But I feel that, how does Python tie into the greater scheme of things? Maybe even go a little bit into the history of higher level programming languages, and to inspire students to say, you learn Python today, maybe you will be developing Python ++ in the future. By the way, I don't know if that's a thing. That's a scary thing, but Python. Anyway, so I Right. And so the industry is really good at throwing keywords. Well, primarily through, slick marketing campaigns and also HR job listings. And I feel that it's up to the industry and also academia to add a context to how things fit into a greater scheme. So to your point about black boxes, right? How do you augment the existing, well, maybe I wouldn't call it a black box, but it's a system with a very complicated and complex inner. How would you augment and add to that, and how that will benefit everyone, how that will benefit the industry? And I think right now this context is something that needs to be developed further.
Thank you, Alan. I mean, that was a great question. As you saw, everybody had a different point of view for this, but we both being in academia, I think owe a responsibility to students to make sure that they come out confident. But I want to piggyback on a question and a comment by Aisha in the chat. Summer learning or summer jobs for freshmen? I would hope, it's a wish list, that every rising sophomore would get an internship in industry, because there isn't much for them on campus in research because they aren't ready for it. And so they sometimes do lose some part of their summer not doing much, unless they got a job on campus to do something. And that, I think, is also a pretty significant opportunity for them to learn. So I'm going to first point that question to Patrick, because he's been doing this forever, through university program, and then hopefully others can chime in.
Well, I think you're exactly right. If I guess a rising sophomore at this point, if that's what you mean by freshman,
yes.
If they get an internship at a company like Infineon, they will be learning. They will, companies don't hire interns just to pay them to sit around and watch. I mean, certainly we don't expect them to do things at a level we would expect, a 10-year veteran to do, but we expect them to be able to do things like do an out-of-box experience with a new kit or something like that, or depending on their level. But there are a lot of things that freshmen can do, particularly going back to UCLA. If they've had a course like Bill Kaiser, they know some programming, they know something about test instruments and so on. So I would say that internship equals learning. I mean, that's kind of the purpose of it too. And also, from the student's perspective, it lets them know whether they like a particular company's culture and what they may want to specialize in down the road as their academic career goes forward.
YC, you want to chime in?
I'm glad you saw my unmuting. Right. So you know what, I think a student will need to be presented very early on with the choice of whether they want to be a part of a company or whether they want to take a more entrepreneurial path like Mihir earlier on. I feel that something that's lacking, and for the lack of a better description nowadays, is the ability to make. I have a friend on Facebook who was so happy that her son is taking a blacksmithing course in Michigan, and he was working on an anvil with a hot piece of iron that's glowing and a hammer. That's what she posted on Facebook, and I thought, you know what? I think students nowadays don't make enough. They've lost the concept of taking something from an abstract idea to fruition. So, for someone like me here earlier on to take a product from his startup company based on his experience that he got from working for companies like Tesla, and turning that into a product, and then turning that into something that he can sell eventually to a big company and successfully exit. I think that idea is missing in the minds of a lot of students, and they have to be presented with this option as to whether you want to make or whether you want to work for a company. And both are great choices in life, but that's something they have to be aware of extremely early on. So maybe to answer Aisha's question, I think, and I am aware freshman and sophomore level students are a bit too young in that sense, or not ready. But perhaps it makes sense to have them do mock projects, present on ideas, challenge each other, get them used to cultures like what you find in companies like Amazon or Google, where you're encouraged to bring up new ideas, but you're also challenged to back it up if you want to make it happen. So that can be done at a very early stage. And I feel that a student who's gone through that and eventually into internships, part-time jobs, and then graduating, that would be a very strong candidate for any position in the industry.
YC brought up an interesting point, and that is maturity level. I mean, there are different, how mature is a rising sophomore versus, a rising junior. Lots of growth going on. For example, over the summer, we had an intern from University of North Texas, and turns out he was also, former military, so he was, older and more mature. So, and already had some training from the military in his electronics and stuff. So to go back to that internship question, from a practical knowledge point of view, do they have the knowledge? Maybe, but from a maturity point of view, especially if they're not going to be local, if we had an intern who was living at home in San Jose, interning in San Jose, that's one thing. But if you take someone from Boston and fly them out here for the summer, that's a whole nother thing. And they might even be, 17 years old, which is a whole nother problem, that they're still minors. So just wanted to point that out.
So let me first interrupt all of you to ask either Sydney or Megan or Kim, how much time do we have left right now for this?
2 minutes, Sid.
Okay, then we are allowed to go 2 minutes over, Kim, if you don't mind, because I want to ask this next question to Nick and Wilson that Kevin Vine posted, which is, does anyone have a feel for how much that is still the case, which is about how much training investment industry is willing to make, and if industry still has the patience to train the incoming students. Nick, I would love your perspective, and then Wilson, you can follow up.
It's a lot to cover in 2 minutes.
Yeah, I know. This always is the case with our panels. Yeah.
It depends on each company's plans and budget, but I think if you look at it as an investment, it can really pay out on the long term, because whoever will be passionate about your company, he will come back and he will apply and he will brag about being an intern and liking it there. And the passion is the best thing to drive to have a very good engineer employee. So yeah, that's my short answer for this lack of time.
Yeah, Kevin,
Thank you.
thanks for
please,
the question.
Wilson.
I would only say that actually industry is in a way modeling academia, in that there is growing investment, particularly to enhance hardware engineers on the values of Python. So a lot of what we've talked about in the two of these sessions are being more and more embedded. I think so in a layer of COVID, I would say that there, at least from my observations, more, I would call it maybe, if it's not patience, intentionality to say there needs to be this lifelong learning in industry, even again, as Patrick and others have said, to help students on that journey of lifelong learning. So I think in short, it's definitely there, at least as far as I could see. And again, this kind of cross-discipline activity, as well as non-engineering cross-discipline. So we see a lot of our engineers being trained on finance, presentation skills, etc. So it's a great question, and one in which I think for a later time, Aisha, I'd like to come back to you and talk more about summer internships, because I think there might be a collective effort to engage not only kind of how companies so-called recruit, but kind of bubbling up this kind of earlier on programmatic activity that might be virtual, might be in person, but I love your question as well. So I think that's 2 minutes, so I'll pause there.
Yeah, we've done this again, okay. And Kevin, thanks for the question. I'm hoping that with ISIDA's willingness to keep the in-person conference going, we will be meeting in person, and the discussions can be livelier and longer. And if there is open bar available, we'll take it. Okay, but this is great. I love the Q&A, and to all the panelists, thank you for your valuable time, making the slide, bringing your perspective. I think 90% of our students are really looking forward to joining industry. And you're right, they don't know at the freshman level what they're going to go for. But if we can collaborate early on, let them know what's out there. We would love to show them the way for what's waiting, both in innovation and in engineering jobs. So at some point, if you are willing for this internship initiative that actually happened over summer, where we had support from TI, I think Keysight, to have interns, and Mario from Rowan was coordinating it. We would love to bring some life into it. We would love to get students get a chance in internship. So thank you all so much. More events are waiting. Kim, you want to take from here and let them know what's coming? And thank you all, really appreciate it.
And we're back in this reality.
Yeah, looks like everyone's rejoined us, and perfect timing. YC, we'll let you take it away, provide closing comments. And but before you do that, I guess we'll see everybody back. We have a day to yourselves tomorrow, or a day to go back to your normal jobs, and then we'll resume the summit again Thursday at 10 a.m. Central Time for another great day. But in the meantime, yeah, YC, if you have a closing thoughts for today.
Yeah, absolutely. So I'm very glad to have connected with all the academics and industry representatives on this call. And it's been great being on the same panel with Wilson, with Patrick Kane, with, Mahir and Aisha. So, I think there definitely is a challenge here, especially in regards to preparing the students for the industry, and also in helping students land the job that they want to be in. And so there also is a certain element of unpredictability. What I hope is that this ISIDA summit, today's ISIDA summit, and also today's discussions, that I hope to be able to bring this offline with you, and also to help drive forward, a way to help students understand what the landscape looks like as an ECE major, or maybe even if they're not in ECE, maybe they're in mechanical engineering with an electrical focus. I would like to work very closely with you, and also with ISIDA in making this happen. And I'm also very happy to hear from, universities on the challenges they faced during the pandemic, during the breakout sessions we had, and how we can better support them. I just want to let you know, if you've ran into any issues, or if you have any feedback or comment for DigiKey, I'm here to listen, and I'm here to help correct and implement things to make it easier for you as a lab manager to support your instructors and your classes. Beyond that, I'm also going to, may I talk about the pop-up idea, Kim? Okay, so So we're also going to be hosting what Kim and I call a pop-up event. It could be later this year in 2021. That will be, just a couple of hours long. It won't be a 2-day 2 days of festivities like the normal ECDA summits. We are going to be showcasing a lot of very exciting things your students can be using to in their capstone projects, and things that instructors can potentially leverage to teach classes more efficiently. So stay tuned for that announcement. But in the meantime, thank you all very, very much for coming on this call today. And I'm looking forward to Thursday. Today we had a lot of great discussions, and Thursday will be absolutely killer. Stay tuned.